This is the November 2022 paper 1, question number 5.2. The question says the function of t of x is equal to k to the power of x plus q has got the following properties. K is greater than 0, k does not equal 1, the x-intercept is at 3, 0, and the horizontal asymptote is at y equals -8. First question is what's the range, second question is what's the equation, and third question is sketch the graph. Before we can do this, I just want to do a quick revision on the different types of functions that we have. So we know that there are about 5 different functions that you need to be able to identify and graph. The first one is a straight line graph, right? You know a straight line graph to be y is equal to mx plus c. And if you were to sketch it, it would look something like that. It could also be a negative graph, okay? Y equals mx plus c. The second type of graph that you know how to do is called a parabola. And the parabola's equation is y is equal to ax squared plus c. You know it more often like y is equal to 2x squared plus 4x plus 2, something like that. That is a parabola, and if we were to sketch this one, it looks like that. More or less, rough sketch, right? Not trying to be accurate right now. The third sketch that we know is called a hyperbola. And the equation for the hyperbola is y is equal to a over x plus q, or you can say y is equal to 1 over x a plus q. The point, the important part that you need to notice here is that x is the denominator. That's where your x is. So in your straight line graph, x is to the power of 1. In your parabola, x is to the power of 2. In your hyperbola, x has got a negative exponent. We could also say y is equal to ax minus 1 plus q. That's a hyperbola. So a hyperbola is the graph that looks like this. I hope you remember. And then our fourth kind of graph that you need to know off by heart is called the exponential graph. And your exponential graph's formula is y is equal to ab to the power of x plus q. Notice here that your x is an exponent. Hence the word exponential graph, right? Our exponential graph looks like this. I hope you remember it. Or it maybe go up more that way. And then our last is a group of graphs that go together. They are known as trigonometric graphs. So y is equal to sine of theta, y is equal to cos of theta, and y is equal to tan of theta. If we were to draw sine of theta, you start at 0 and you do that. If you were to draw cos of theta, you start at 1 and you do that. And if you were to draw tan of theta, you would have your asymptotes. So you would do that and then come up by your asymptotes. So those are the 5 different types of graphs that you need to be able to identify. The reason why I went through this is because they don't tell you what type it is, but you need to be able to identify. So the t of x is kx plus q. Since x is an exponent, we are looking at an exponential graph. Right, we have identified we're working with an exponential graph. So what are the important things to know about an exponential graph? First of all, this first bullet point is part of the definition of an exponential graph, which is that k must be positive and k cannot be 1 for an exponential graph to exist, right? So k must be positive and it cannot be 1. It can be a fraction. It can be a half, but it cannot be negative a half. It cannot be 1 on its own. Let's start. I'm going to try and sketch it. Let's start with the sketch first. So question 3 first, right? If we were to sketch this graph, we would draw our axis. And according to bullet number 2, it says there's an x-intercept at 3, 0. So if that's 1, 2, 3, it means at this point, the graph cuts the x-axis. The other thing it says is that there's a horizontal asymptote at y equals negative 8. So on this graph, 1, 2, 3, 4, 5, 6, 7, 8, I have what we know as an asymptote, which means that an asymptote is the line that it tends toward but does not intersect, which means that my graph will look something like, no, that's the wrong line, something like this. I think my graph would look something like that. So let's answer the first question. What is the range? Range, if you remember, question number 1 speaks to the range. If you remember, range talks about all the values of y that are valid, right? So which values of y are valid? If you look at the sketch that we drew, we notice that the graph does not go here. So below y equals negative 8, the graph does not go there. Above y equals negative 8, everything over here is valid all the way to infinity, which means that my range is going to be y must be greater than negative 8. Everything greater than negative 8 applies to this graph. Let me see if I can, okay, I'll come back to this one. Question number 2 says, what is the equation of the graph? So let's see if we can do that. To get the equation of the graph, we have the generic formula, or let's use the formula they give us. The t of x is equal to k to the power of x plus q, right? You normally know that this value here, the asymptote, is going to be your q value. So we can substitute that. T of x is equal to k to the power of x. Now I'm not going to say plus q, I'm going to say minus 8. So far so good. Now the question is, at the x-intercept, y is 0, right? So I'm going to go and I'm going to say at the x-intercept, y equals 0. And I know from the text that the x-intercept is at 0.30. So my equation says y is equal to k to the power of x minus 8. What happened now? Okay, 0, which is that one, is equal to k to the power of 3, which is that one, minus 8. I don't know why I keep writing up plus, minus 8. So now I'm going to solve, and I'm going to take the 8 over by saying plus 8 on both sides. So that means that k to the power of 3 is equal to 8. Having done that, I am going to do a cube root on both sides. So that means that k is going to be equal to plus or minus 2. So far, so good. I hope you understood what happened. So what are we saying? We're saying 2 times 2 times 2 equals 8. But also 2 times negative 2 times negative 2 is also equal to 8. And I'm looking at this positive 8. So k can be positive or negative. This means that my equation, now that I have the value of k, I can substitute it in here, and I can say that the t of x is equal to, I don't need a bracket, 2 to the power of x minus 8. and that is going to be your final answer. That's the answer for question number 2. Then question number 3 says sketch the graph, which they're saying clearly indicate the intercepts with the axis and the asymptote. So our asymptote is over here with this dotted line. Let's take this away. So I'm gonna write here asymptote. Okay, hold on. Asymptote, and then I have here 0.30 is my x-intercept, and over here is going to be my y-intercept. Are we happy with that? Okay, let me show you a different app. So the app I wanted to show you does not do exponential graphs, which is okay. I think though perhaps our y-intercept should not be here. I think our y-intercept should probably be there because it tends towards that. So it's going to be at 0.7 for the y-intercept and not at 8 because it never touches 8, remember? All right, so that, ladies and gentlemen, is the end of question number 5, if I'm not mistaken.